Hello, welcome to tutorial 10. We're in the 10th episode, which is nice and exciting. Thank you very much for watching along, and I hope you found this interesting. Um, any suggestions, put them in the comments and things. Talking of which, Solar, thank you for following along. I don't think you've caught up with these videos yet. You're on like episode 5 or something, or part 5. Um, and I'm really sorry, you said from an earlier tutorial you were working on like a red zone, and then you've made like a biome and blended that from plains to deserts and things. I guess yeah, in that like early one of those early ones was that part 6. Okay, you're kind of close to this now, where we had actually this screenshot, this thumbnail is from like the first video, I think, where we've got like red and green and blue and things like this. Don't worry, you can we can still do the same colors in the latter versions. Okay, so this video, although biomes, solar biomes, we should do. If not this video, very soon. But it's a special video, so maybe I'll try and cram as much in as possible. Talking of which, first thing I've got to do, so this is the code from last time, and what I usually do is save this as the next tutorial. So this will be 10. Save that. And now, so we're in file number 10, and now I change this to tutorial 10. All of these tutorials and all the assets that I use in these videos are all online on GitHub, and you can just follow the link in the description. So if anything goes wrong or is not working, maybe just use my code and then adapt it, and that should be fine. Certainly from what was it, part 8, that's when we corrected everything with the textures and the models and things like that, because Unity updated, corrected a mistake, and my system, the way I was doing things, was wrong to begin with in the earlier episodes when I was loading models and loading textures, and it only worked because of a bug or an oversight in the original code. Anyway, thanks to Peter Amland, everything is working brilliantly. Peter Amland, remember, is the creator of Ursina. Right, we can delete all of these done things just to clean up the list at the top. Tidy NumPy imports, the new repo. Oh yeah, that's all done. Trees we want to do. Axe model, I thought, as a celebration. I featured that in like an earlier, like maybe the first part, but never came back to it. So we should definitely do that. And what was I just going to say? Oh yeah, before I forget, last episode and a few episodes I've been using this like old version of Paint remake called jspaint.app, and I just wanted to credit the person who made it. I found out it's Isaiah Odner, who has a very interesting website. I was kind of like tracking it down, and wonderful like projects and things. So if you do like coding and programming and stuff, maybe go and have a look. I'll try to remember to leave a link to this. If I don't, it's isaiahodner.io. Just look up Isaiah Odner. So he's made this wonderful paint clone, and in extras themes we can go dark mode. And I've just broken it. Oh no, it's fine. Sorry, Isaiah, if you ever watch this. Almost broke your wonderful code, but there we go. So now we're in dark mode, which you couldn't do in Paint as far as I know from the 90s. Right, how do I want to just, I can't even use it. I want to clear selection, lovely, and now I want that all, let's go kind of like light grey in case we have to do any diagrams or anything. Right, so first thing, we need to get our diamond pickaxe involved. Then we need to work on our caves and our trees. That's the main thing that we're going to do. So number 6, axe model. So if I go to my folder, so my main file is tutorial10.py. So that's what we're looking at here, all the code for creating the terrain, setting up the Ursina app, the textures, everything else. And then last video 9, we set up our own module and wrote our own class for handling all the cave building stuff. So that's the way we're going to continue developing our project so it's much more organized. So we've only got these like 2 files really, and we do have um, another module that we did use, nmap, from like part 4 or part 5, something like that, that just has one function in. But also in I've got all of these other files here. So these are all the other versions from like tutorial 5, tutorial 4, and so on. Hopefully your folder will be a lot tidier. So just nmap, your main module, and then the caves module system. And then you'll have a folder called assets. And this is where, you don't have to call it assets, but it's a tradition to call it assets. And that's where you keep all your assets, namely textures and other things like that. So I've got the Minecraft chicken in here, grass texture, the monochrome texture, wireframe texture, and terrain models and things like this, mobs. And I've just put in here diamond pickaxe. So you can just grab this from my assets if you need it. I found it on Sketchfab, which is a very good website for hosting models, and I think it was in a FBX format or something, but I've converted it to an OBJ file so that we can use it correctly with Ursina. To do that, just go online and search like FBX to OBJ, whatever file types you want to convert between, and you'll find a free website to do it. Let me just show you the one that I found, because it is very good actually. Let's just say FBX to OBJ and see if it comes up. This is the one that I've used. Yeah, Aspos. Yeah, Aspos is absolutely fantastic. You can convert between anything to anything. So if you want to do WAV to MP3, MP3 to WAV, all kinds of things. I'm not sponsored by anyone, so I'm just suggesting this because it's really, really good. There you go. So if you download anything from Sketchfab, any models or anything, then you can use this place. Right, so let's get back to our folder. So, oh, that's not our folder. So I've got the diamond pickaxe. So it's called diamond hyphen pickaxe, both capital letters, obj. See if I remember that. And then I've also got in the materials folder, I think I want to use this one, diffuse PNG. Again, it's a capital letter, diffuse. Right, let's go and set that up. So in our, not in our cave system module, but in our main, what should we call this? Like, we'll call it the main module. Main module. I'll try and call it that. We want to go and get our diamond pickaxe model and texture. So I'm doing that all kind of here, aren't I, at the beginning? So let's comment this part of our text as well, our code. Load in textures and models. Again, probably be a good idea to have like another module to do all this, maybe. Anyway, we'll call this axe equals, and actually, it looks like I've got a bit of a naming convention. I'm calling my models whatever it's kind of called, and then model. So I'll call axe model equals, and that was called, can I remember, diamond hyphen pickaxe dot obj. And actually, remember, Ursina should be good enough to go and find it without even putting the file name on. Let's try that. There was another model version with a different file name, so it might not find it correctly. Anyway, let's see if that works. And then axe text equals, I just heard my chihuahua sleeping over there, and it made the sound like a it's like a creaking door plus a pig. Anyway, she looked very, very happy, which is nice. Axe text, and then it was diffuse.png. Again, let's test that and not put png. This is a bad name, diffuse, because maybe you'll have other textures called diffuse. Diffuse just talks about the quality of the light or the lighting that's used on it. So we should go and probably rename that. We'll call it diamond underscore axe text. There we go. .png. Oh yeah, I wanted to test it without the PNG. So let's just copy that name, and then I'll go and rename this in here. Oh, by the way, if you're just going to grab these models from my assets, then you don't have to do this. So you're welcome. I'm doing this all for you. Right. Rename that. There we go. Diamond underscore axe text. All good. Okay. So that's there. Now let's go and load this. How do we do? How do we do this? So it should be very simple. Yeah, we'll create this after our subject. So right down the bottom is where we create our chicken, Vincent, or Mr. Goose, baby, our giant axolotl, and under the subject, I guess the axe belongs with the subject. Our axe, big smiley face, and let's just call it axe equals entity. Gosh, a while since I created an entity. I can hardly remember how to do it. And then we're going to set the model to our axe model. Okay. Scale we're going to have to change, I imagine. Let's just set the scale to 1 at the moment. I think usually when you take things from Sketchfab and Blender and things, the scale is like absolutely massive. And what we want to do is let's parent it to our subject. So that means we've kind of glued it to our subject. Wherever our subject goes, our axe should also go. And also, if we rotate our player, the axe will also rotate. But we want to kind of position it first. So let's say position equals subject.position. So it's squarely with our player. And then we kind of want to move it slightly forward. So we'll say Z, so Z axis will be back and forward. Z plus equals 3. Okay. Where is the player? So the player is there. So I have to do this here, really. I'm just thinking Z plus equals 3. So I was just thinking, just in case you might want to, or I might want to, place my subject. For example, yeah, I've put us at 5. So that's where we're positioned, not at 0. And then if we try and position the axe close to our player or something, or on our player, or maybe at 0, 0, 0, it will be behind us or something strange like that. So I just want to say move the axe to exactly our player's position. So it doesn't matter where we've put them, it'll be zeroed in on our player. And then after that, move the axe 3 units forward. That's the idea. That's what should happen. Okay, so that's there. Another thing that we can do is, anyway, I was just thinking about it might disappear behind things, but there's something we can do about that in a moment. Right, let's just see if we can see our axe, first of all. And we can play around with its rotation and its scale and its position if it's not right. Maybe we won't even be able to see it. Oh! I thought that was the terrain. And I was like, we've really broken everything. Okay, our cave is still working. Vincent's there. But our axe is a giant axe in the sky. That's because I haven't parented him. I was getting distracted by positioning him and then explaining that. At least we've got our axe. Although our texture doesn't seem to be working. Maybe it wasn't diffuse I was supposed to be using. Oh. I haven't applied the texture. So I didn't do two things. Okay, right. Texture equals ax text. There we go. And we want to, when do we want to parent it? Do we want to kind of, yeah, after we've positioned it and rotated it, then we want to parent it. I think that's the idea. So we want to say ax.parent equals subject. Okay, let's just have a look at that. I'll have some tea. Okay, we've got our texture. Texture worked. And as we're moving around, he is parented to us. So if I look up, it's in front of us over there. If I go over here, look up, it's parented there. So we definitely need to make him smaller and kind of bring him down to Earth. Even though he's at our position, he's kind of like stuck really high. So let's try scale 0.1, so that'll be 10 times smaller. And then let's go ax dot y minus equals 10. And we need to, it was kind of like this way, wasn't it? So we need to rotate it on its z-axis. And that should be fine. That should be fine. Ax dot rotation underscore z times equals I guess 90 degrees, not radians. Let's see if that, see what that looks like. Oh, it looks really small now. It's still not close to us, is it? What if after I've rotated it, I say ax dot y equals subject dot y? No, it's really high. Minus 32. Is it something weird to do with our start height? Yeah, maybe. Anyway, it's tantalizingly close now. This would be a nice screenshot. Yeah, I should feature the axe in the thumbnail. That's not exciting. I don't know why I got excited about that. That's not entertaining. Right. So the rotation's going wrong. What's going wrong here? So what this must mean is that our model, or might mean, sometimes this happens. Whoever like built it has used a different coordinate system. So its z might be y or something like that. So what you're doing might not make sense. Let's try the x-axis by 90. In whatever case, something needs to be rotated by 90. So I shouldn't try lots of different things, else we'll get confused. We should just do one thing at a time. The size seemed about okay. Let's just double its size, go to 0.2. Yeah. So we'll get the rotation and the size kind of okay, and then we need to bring it backwards or forwards, I think. Okay. So we're still the rotation is not right. So I guess we haven't tried the Y rotation, but it's about the right size, I think. It's hard to tell really with the perspective right now. Try Y, and then I think it needs to be a bit closer to us. Well, the rotation's not happening, is it? Okay. let's do 2 rotations. So we thoroughly confuse ourselves and don't really know what we need to do. Oh, that's really odd. It's not obeying our rotations. What might be happening is because we set the parent to our player. No, well, we're setting different positions and scales and things, and that's going fine. Okay, let's just try, instead of times and equals, maybe that's not okay. Maybe we just have to set it to exactly 90. Oh, yeah. Yeah, because it might be 0. The rotation might already be set to 0, so anything multiplied by 0 will be 0. So that's maybe what I was doing. So let's go back to the Z axis, which it should be, I think, equals 90. And then we can change it to minus 90 or whatever we need. Okay, that's what I was kind of expecting to see, something like that. Now the only problem is I think I've got it facing towards us backwards. Oh, and it is massive actually, isn't it? You can see it going through blocks that are about, what, 1, 2, 3, 4, 5, 6, 7 meters away. So it's much too large and it's facing the wrong way. So let's try minus 90. And our scale wants to be, I'm not really sure, maybe 0.06, something like that. And let's just see if we can still see it from that perspective. It's now upside down. And it's still really far away from us. So I think, was it too small? Let's just try 1 then. And then, oh God. So we'll stick to 90 and then rotation Y. So this one, we just need to flip it by 180, don't we? Equals 180. Okay. Oh wow, it's looking just about right. Okay, so now all we have to do is get the position right and kind of the scale. So it's going inside of a block and it looks like it's about the same size as a block, which is about 1 meter. Is that about right? It's kind of big. Okay, that's about right. So I want to bring it into left slightly and then back. So I'm moving it forward by 2, so maybe just by 0.6, and then yeah, the scale was okay. Oh, and then I want to move it left slightly. So I'll do that here as well. Ax dot y. I'll do this all before. I tend to do movement or translations of position before rotation. That seems to be a good rule of thumb with 3D graphics. Else, you might, let's say, rotate something and then translate it, and it might be using its own like coordinate system. And then if you just try to move it left, instead of just moving this way, or to you going this, oh no, I was doing it right. If I go like this way to move it left, it might instead use its own coordinate system. Now that you've rotated it, it might go up like that, something unexpected. So if you move it first and then do the rotations, things usually go a bit better. Anyway, we wanted to go left. No, not its Y position. What am I talking about? Its X position. Minus, let's just try 1 unit to the left. And oh wow, that is very close. It feels like it's kind of in my hand. So I do need, although it's actually, these blocks are really far ahead of me, aren't they? So it needs to go back quite a way. let's just say z equals 0, which shouldn't really change anything. And maybe it does have to be a bit smaller than this. And we'll go 2 meters this way, or 2 units this way. I think I'm going to have to make it smaller. Okay, so I can't see it, so I presume it is like right with our body. So let's just say plus equals 0.6 ahead of us. Yes, that's about right. No, a little bit too much. 0.3. So you might be thinking to yourself, there must be a quicker way of doing this. And there is. What we should probably do is maybe code it so that you can use the arrow keys or some keys, even the WSAD, just while you're debugging this, to move the axe, and then on screen or just print to the terminal its current position and rotation, and then you can just literally do it in front of you like a mini editor, and then yeah, that would be much better. Right, so I'm just about happy with this. Maybe move it back slightly, but yeah, it is too far ahead of us, isn't it? But the size is, I don't know, maybe a bit big. So it's 0.3 ahead, so maybe 0.1. Make the scale 0.07. So yeah, fiddling around with the numbers here is quite difficult. Although we're getting very close. So it'll definitely be worth doing like a little editor. I'm not going to do that because I'm just so close, and I've kind of just like hacked my way there. Right, the other thing is when we're looking up and down, it's not moving. So, oh, I've kind of moved it forward now. The size now looks a little bit better, I think. So I do need to move it back. What was I going to say? Oh yeah, we could, instead of parenting it to our subject, we could parent it to the camera, because the camera object is being moved up and down and left and right with our mouse, which is itself parented to our subject, or maybe the subject is parented to the camera. I still want to move. Well, let's parent it to the camera. So I should just be able to write camera instead of subject. We've not actually made the camera entity. That entity is automatically made via the player, first person player prefab. So that's much more like it. We're looking up and down, and there it is. So yeah, we just want to move it back maybe, and we could change its rotation a little bit. No, I'm not going to fiddle around with the rotation. Right. Let's just move it back a bit more. Oh, it doesn't even. Maybe I'll just leave that. Oh, I've now said subject position. I want to. I kind of do want it subject position. Right. Okay. Okay. And we want to make sure it appears over the top of everything. What was that? It was something like always on top equals true. I don't know if that variable is correct. Let's just see if that works. Else we'll go to the documentation online. I still need to move it back slightly. It is no longer disappearing. Fantastic. So now we do just need to move it. Let's just try, because we are parenting it to the camera, let's just see what happens there. It'll be even worse. Okay, we can't see it, which may be good news because I haven't actually moved it forwards. Try 0.3. Oh my god, half an hour of fiddling around with the axe. And now I can't see it anymore. So let's put it back. Let's position, subject position. Oh, now I wanted to move it backwards, didn't I? Let's try moving it back 0.3. Still want to come back a little bit more. Maybe a whole unit. And back even more. Now I can't see it. Oh man. Oh, I should have. Right. Okay, I'm very close. What I need to do is just pause the video, isn't it? Sort it out and then just show you the numbers. Let me do that. Let me do that. See you in a moment. Okay, welcome back. I think that only took me a minute. But we've got x is minus equals 3, z minus 2.2, and y minus 32. Yeah, this can't be a coincidence. We're starting at 32, and its position should be... I can kind of see what I'm doing. I should start the axe position at 0, 0, 0, else... Let's pause this again. Okay, welcome back again. Terrible solution, but I've just said the y position of our x minus equals, so decrease it by whatever our subject's height is. So if you want to have a different height, then it doesn't matter. We're not putting in like a magic number in here, like I'm doing for these other adjustments. We are just saying, just take off whatever height you were. Basically what I should be doing, and maybe experiment this with yourself, I'm not going to do this like on camera, but maybe have an experiment with just positioning your axe at 0, 0, 0, then making it the parent, and then maybe changing the scale of it afterwards. I think all of these things, just as in translations and rotations, the order of them matters. It's kind of like its own syntax. Anyway, I've kind of shown you, if you don't do it properly and don't really think about it and just do it quickly like I did it, you may have a little bit of fiddling to do. Anyway, we've got an axe. We've got an axe. Right. Next thing we want to do is our caves and trees. I think I want, since we're dealing with models and things, let's make some trees, and that will kind of warm us up for the and work closely with our cave system. So the axe model is done. Fantastic. So trees, let's try and do this now. Okay. So here's our cave system. So we made it like a class that initializes, it builds the caves at certain positions. So it's maybe something we could do with like trees. And then it checks to see if there's a cave there. What we could do, I think, is when we generate our terrain, every time we've placed a terrain subcube, where are we? Generate Perlin. Yeah, here we are. Generate the terrain. So remember the first thing it does is decide where to place a new terrain cube. And remember, we've got like an infinite terrain system, and the first thing it does is say, is there some terrain here already? If so, skip over to here. And basically don't place a, yeah, there was terrain already there, so continue rotation to find the new terrain spot and to generate it, and so on. So it's not placing down any terrain if there's nothing there. We're also deciding if there isn't some terrain there, so it does generate a subcube or decide where to position it, and then it goes to generate the Perlin noise function. And that's where we also refer to Anush, who is our cave system, and it checks whether there's a cave there, and then it moves the terrain down. So what we could do here as well is, if there isn't a cave there, so that means we must be on the surface and we must be generating some new terrain. So we only do that once. We could now place a tree, or go and see if we want to place a tree according to some other Perlin noise. That makes sense. Yeah, because we don't want to have our subject wandering around and then just generating loads of trees, else it's just going to slow things down and become very chaotic. We want to say only if we're placing a terrain cube. So we want to say, okay, we could build a tree there, and then we want to go and check it, make sure there's no cave, which we've already done here. So we've done that piece of programming, and then we want to say, is it against some Perlin noise okay for us to build a tree here? And then we can play around with how many trees are going to be in a certain area. So some forest biomes and things like that we could play with, which I'm sure Solar, I'm sure you'll like that. Right, so if there is so we'll do this in the Perlin noise function. So we want to say something like this, else we want to refer to our tree system object, which we haven't made yet. We'll call it Solar after our, oh, if you can type better than I can. Yeah, Solar. Oh, it'd be cool if we spelled it with a 4. Yeah, let's do that. Can we do that with variables? We'll find out. Solar, and then we want to, we'll call it check tree. And what that function will do, yeah, is at this X and Z location, we'll go and try and build a tree. There we go. Now, we've got some problems here because Solar doesn't exist yet, check tree doesn't exist yet, so that's what we just need to write. But we've got just one line of code we've added, and that will be our whole tree system. As far as our main module is concerned, just that one line will handle all of the trees if they work. And that's the beauty of organizing things through classes and modules. So let's, at the top, before I forget, let's write what we want to be able to happen. So just like we said from cave system, which does exist, import caves, we want to say from tree system, import, we'll call it trees, I guess, and that will be the class name, and that we called Solar. So create a cave system object, it's called Anush, and we want to do the same thing. So same again, but for trees. I feel like a smiley face is needed there. So we want to call that Solar with 4 equals trees. There we go. And now, if I go back to the Perlin noise, this makes some kind of sense. It says, okay, there's an object, a trees object called Solar, and it must have a member function called check tree, which can take an X and a Z. floating number, or it might be an integer by this point if we wrapped it in int. Okay, so we need to go and build that module. So I'm going to create myself a new text file, and I'm using VS Code, I think, so I'm just going to select Python. There we go. I'm going to adjust my screen slightly. Oh yeah, I teleported into the conservatory. You probably noticed that. I just did that. So this, we're going to use a text string. We're going to say this is our tree system. It plants trees, if appropriate, having been called from the gen Perlin function in our main module. So I just wrote that to our future selves when we read this back in a year, when we're like, you know what, let's improve that old Ursina Minecraft clone that we did in 2020 or 21. And then we're like, oh yeah, I want to go and improve the trees, and we have no idea how this module works anymore, how it interacts with the other module. Because we've written this, our future self will know what's going on. They're like, oh, I need to go and have a look in generate Perlin or whatever. Right, so just like we did with our cave system, we're going to write a class very similar to this. In fact, so similar, let's just have a cheeky copy and paste. Right, copy that bit, paste him there. So class wants to be called trees, and now our initialization or constructor function. Again, I've used the this keyword there. Remember, that's like a functional thing behind the scenes that allows a class to refer to any instance of the class that you initialize. For example, we've called our instance or our object solar, just like we called our caves object Anush, and just like we called our Ursina application object app. There we go. Anyway, that works because of this keyword. Usually in Python, it's called self. I'm just going to say that again. And so all your member variables will be called self, and so on. But I like to use this. So I'm going to call it this. And it does prove the point that you can call it whatever you like. Okay, what do we want? We want, basically, I think, we could do it like the cave system. We could have like a dictionary to say where all the trees are going to be. But actually, let's use some Perlin noise. First of all, let's just save this file. So we've got to call it tree system, I think. That's what I referred to it as in the main module. So tree underscore system dot py. And let's just make sure I called it that when I tried to import it. From tree underscore system import trees. Okay, so it does exist now. Which means this shouldn't be wiggly anymore. It might be because trees isn't, the trees class isn't complete yet, or has some issues in. Anyway, let's have a noise variable, and that's going to be from the Perlin noise module. So we're going to also have to import this in our tree system because we want to use that. Just because our main program is importing it doesn't mean that it automatically gets imported for all these other modules. So we have to import things individually. Just as if we need to use any colors from Ursina, we're going to have to import Ursina color here. Anyway, so we've got a Perlin noise class there, equals, oh, I think I can just say Perlin noise, can't I? Perlin noise, and then octaves, oh, automatic is going to be 1. But it's nice to add our own seed. And so let's do it 4 in honor of Solar, because he's got 4 in his or her YouTube name. Right. This noise equals Perlin noise C 4. Okay. Then I guess we're going to need a check tree function, aren't we? Okay, that's what we need to do. Right. So define check tree. Remember, the first like dummy parameter we need in there is our self, or this keyword, and that now we just need an x and a z. You don't have to use these underscores, by the way. I haven't talked about this in a long time, but for parameters where you pass in arguments to functions, values or variables, I just like to use an underscore. It just helps me. It helps me tell the difference between a parameter, a variable, and any variables that we make in here, just so I can keep track of that. Okay, so remember in here, in our main module, we're in Perlin noise, and we're saying if we can create some terrain here and we're not making a cave, then just go and see if you want to plant a tree at this position. So then what we want to do is in our own trees Perlin noise is generate some Perlin noise. So let's just use one of these octaves. So actually, talking of temporary variables, so we've got some now, local variables. As soon as this function has finished, this frequency and this amp will dissolve. They will be taken away from memory. So they're completely different to these variables that are generated and created inside the function. If you want to use a variable outside or from outside the function, remember use the global keyword. Have I got an example of that? Yeah, so in generate terrain, current cube is created somewhere else and it's used in maybe many different functions. So that one variable is what we call global. It's globally available, like all over the world, all over the different functions. And it's not a local function. That will be deleted once a function's finished. Okay, so we're saying our frequency is 32. So let's just change this. Let's just say something like 2. So that frequency is very choppy. And then our amplitude, so we're not talking about like the heights of trees, we're talking more about like the probability of the trees. So if we have like an amplitude of say 100, and then we say y equals this dot noise, so we've got to refer to the noise object that is a member variable or held in this member variable of our class. So this dot noise, frequency and amp we can keep the same. If the result of this, we can then say, or let's call y tree chance. So it's like, what is the chance of a tree being generated? And it can be as high as 100. So we can then say if tree chance is greater than, I don't know, 70, plant a tree. So then we want to say this dot plant tree. I guess we want to tell it what our x position is and what our z position is. There we go. This function doesn't exist yet. So we've got to go and write that. And what are we doing? We're basically creating a tree model at a certain location. So again, first parameter we need is this, or self, if you're using the proper Python terminology. X and then Z. Hopefully it's not confusing. I'm just using XZ, XZ, XZ the same. They are different. They're separate parameters belonging to each function, but they mean the same thing. It's like check tree is getting passed X and Z from Perlin noise, and then it's passing it into plant tree. So it's kind of like filtering through these different functions. And then we want to say, yeah, E equals a new entity, model equals, we want to make our own tree model, don't we? I guess what we could do is create like an empty model, then generate like the head of the tree and the trunk of the tree, and parent those to our entity. So I'll say none. I will say, what is that? We call it tree, is there. And its position equals, I think we have to use vec3 object, and then we want to say x, we need a y, we need a height, and z. So actually, we need another parameter. So we need to pass in here, the height of the terrain. So we need to pass in y. So it isn't underscore y, it's just y. And I've used it after or between x and z, so we go x, y, z, so it doesn't confuse us. So it doesn't have an underscore because it isn't one of these parameter things, it's created as a local variable there. So we're going to pass in that there to check tree, and then check tree needs, I'll use the underscore y here, and it's going to pass that into plant tree. Okay, so it just takes that underscore y, passes it straight through there to plant tree, and then I've already made that there. Okay. So its position, is at the height of the terrain, and also you can maybe move that up a little bit. But there we go, we've got the position. Right, that's all I think we need to do there. So then we'll call I think it's called the crown of the tree, where all the leaves and stuff, or the canopy. We'll call it the crown. So that needs to be an entity. Now this reminds me of doing the diamond pickaxe, where I got everything wrong. So its model wants to be a cube, and let's just put scale equals 6. And then y equals, we'll put that 9 units in the air. Oh, I forgot a comma there. And then trunk equals entity. It's also going to be a cube, but then we're going to play with the scale. We're just gonna, let's just play with the y dimension. So y equals, we'll make it, I guess, 9 high, or 9 long, 9 tall. And we want to change the color, don't we? We want this one's color to equal color dot RG. Oh no, we'll just say color dot brown. And then for the crown, want to be some kind of green. So we'll say color equals color dot green. And later on, we can be more sophisticated with that. We could add some maybe randomness. We could use some more Perlin to change the colors. Solar could use like biomes and things, but we'll just use color green and brown for testing. And now, the final thing is to parent those to our tree entity, and that's just like an invisible like I don't know, like folder that we're just kind of like placing our crown and trunk inside. And then if we need to change its rotation or its scale, we can just change the scale and rotation of this parent entity. Now we don't have to fiddle with all the other parts of the tree. And you might make trees, or I might later on make trees with branches and other things. And so imagine if we want to change the size of everything, we'd have to go through all of those different models, and it would take a long time and be basically impossible. So this is why I'm doing that. So we want to say crown.parent equals tree, and it's going to get another child, the trunk. Parent equals tree. Now, and I think that's that finished. So it's created a tree there, or planted a tree. We've got underlines for vec3, entity, and color. That's because all of these functions or objects belong to Ursina. So we've got to import Ursina at the top as well. So we want to say from Ursina import. We don't want to import everything, because that would also import the main function, actually, the main initialization, and that would create like two Ursina apps going on. And also, we don't need everything from Ursina, so that's really bad practice. We just need entity. We also need, we need to also write import. Import entity, we wanted color, and we wanted, I think vec3 is here as well. So that all looks good. It's all gone like orange, which is nice, and no underlines. Lovely. My goodness, I think we can actually test this. So let's just let's just run this once through our head. So in our main function, and let's bring that over here. In our main, module, in generate Perlin, if we want to create a cave, we do so. Otherwise, if we're in Perlin noise, it must mean we're allowed to create some terrain. So we're only creating this terrain once, and then we never go back to that area. And then we just want to say, if there's no cave, go and check if we want to put a tree there. And we're going to pass the X, Y, and Z position of our terrain at the moment. So then in our tree system, in check tree, we then calculate some tree chance using some Perlin noise. And I'm trying to say, if that Perlin noise returns something above 70, so it's a bit like above 70%, then plant a tree there. And then in this plant tree, we're creating a model, and it's probably going to look terrible or not work at all. Let's go and see. And we're just under an hour. Right, there's our axe. And I can't see any trees yet. So we'll have a little bit of a wander. Now, possibilities are, one, just something very terrible is going on. That's really bad with the class system. Two, that Perlin number, 70, was too high. So we just need to make it low. And then three, there's something wrong, perhaps, with the model that we're trying to generate, maybe, or the entity that I was using. So I'm not seeing anything. Let's just go to our caves. It feels like I'm playing Minecraft now, like I've got the axe walking around to different places. So I'm just seeing, are there any trees weirdly like underneath the terrain or something like that? No. So I don't see any there. Okay, so let's go to our tree system. Oh, I should have had a look through the terminal to see if anything else was going on. Models 9, models Q, vec3. It's got its position. Scale is 6, scale Y is 9. Maybe it needs a texture. Or maybe, no, it'll automatically be like white cube, I think. So I don't think that's the problem. So let's just try if it's greater than 7. And we could also maybe print out, if we don't see anything this time, we could print to the terminal what kind of numbers that Perlin noise is returning. Okay, I think these are all trees. So it was like option number 3 or something, and these are our tree trunks. Oh wow. Hey, it's still playable. Our trees are kind of working. Right. Oh, that's good. So it's working. It's basically working. So it just so happened that that chance was not great. So let's just try 30%. And I also want to print out tree chance. And that needs to be a string. So we'll get some idea, tree change, tree chance. We'll get some idea of the amplitude and frequency. Oh, it's because I'm using frequencies. Oh, I don't know. I don't know. That's why we're printing out to the terminal to see what's going on. Okay. Wow, our trees are pretty big. They don't quite look like trees yet. I need to lower down the canopy, the crown. It does feel like we're underneath now. If you like a kind of forest biome, 30% looks pretty good. So we need to lower down the crown and maybe lift the... let's go to our cave to have a look underneath. We don't want this kind of thing happening, where they're competing for the display of the texture. Okay, so yeah, we can see like the tree roots about 1, 2, 3, 4 below. So tree system, let's do that. Plus oh yeah, we can just lift the whole tree now, can't we? So we can say tree dot y plus equals 5, and oh, it would be nice to look a little thinner actually. The trunk. So we could say scale. I guess the scales on the x and the y and the z equals 0.6, we'll say, and scale z equals 0.6 as well. Don't forget the comma at the end. So kind of like squeezing it, each one. Oh, and we needed the crown to come down a little bit. So that needed to go down, I think by 1. We'll try 2 though, so we'll go down 7. And now, oh yes. Oh, did I closed down the terminal again, I think. So, can I? Yeah, I deleted all the all the interesting information. You probably saw the numbers. Wow, so they're really quite low. Oh, it's because of the. I forgot the what's it called? Sorry, the frequency is really low, so they're kind of like really jaggedy. Okay, so they're now floating exactly like 1 above. Oh no, not exactly 1. So it's about 1. So I need to lower them by only a little bit. But yeah, they look more like trees now. Oh, we could give the trunk a collider. That'd be good, and then we wouldn't walk through them. and I was just on about 60 frames per second just then, but I'm still looking comfortably. If I'm looking at everything, I was going to say it was over 30, it's now dropped to 18. It's because I've got so many trees here. Let's try a simple biome, and then I want to finish this tutorial video because we're over an hour now. So firstly, wanted to move the tree down slightly, 4, and then I was happy with kind of like the scale of him. Then I might, you know what? Let's get hold of, oh yeah, scale first, and then tree dot rotation y equals random rand int between 0 and 360. So random doesn't exist in here, so we need to import that. Oh, actually, I should import it in the local to the function, I guess. From random import rand int. There we go. Oh, now I can just say rand int. So yeah, each tree will be like rotated a random amount, and now we want to set this. If I set the frequency to 1, what kind of numbers are we getting? Let's just have a look. And I've just accidentally tried to run this from the tree system. I need to run it from the main module. And I don't need to drop from so high. Oh, that's really strange. It looks like all the trees are being planted. We're getting several trees being planted. There. That's bizarre. What's going on there? It suggests that actually we're trying to generate more than one terrain subcube. Or hopefully what's actually happening is that they're not being positioned right at the center of our terrain, but in its corner, and then several trees are able to overlap. Maybe something else is going on. I think though that's really odd. What's quite nice is that the frequency being so, hello Vincent, being so low means that there's like this little biome over here, or area, not biome, little area with trees is occurring, but not in other places. And you can kind of see the numbers on the left here are like hovering around 0, and then they suddenly change. But yeah, it'd be fun for you to like play around. It's always fun playing around with the octave numbers, the frequency and the amplitudes to get things. I'm very confused by this bug though. Like this tree, you can see there are several trees have been planted at this one position, which should be impossible because we're only asking to plant one tree, and it's something to do with moving the player, because this terrain was already generated. and yet Gen Perlin is being called again when I'm moving over here. Okay, so there's something going on with that. So I'll have a look at that behind the scenes. It's almost like I'm planting the trees. I'm sure this has got something to do with our with our gravity system. So generate Perlin is not only being called by generate the terrain, and I've got an accidental gap in the terrain here. Very mysterious. Oh, that's just because it hasn't generated the terrain yet. If I sit over here, it should. Nope. Okay. Right. So let's exit. Strange motorbike sound just then. Sound a bit like gunfire or something. So tree chants. I think I was happy with that. Oh, I deleted the output again. Anyway, we saw kind of some numbers. Right. Anyway, what do I want to do? I want to add to the trunk a collider. So say collider equals box. And that should just be a very simple collider. So therefore, the least demanding collider around the shape of our trunk. If that doesn't work, if that doesn't scale correctly, we'll use mesh, but I think that should be fine. It should take into account the scale of the object. Then, yes, we wanted to sort out the main problem. So, this is really nice for illustrating the fact that in our generate Perlin function, we're doing stuff about creating caves and we're checking and planting trees. That shouldn't be happening in generate Perlin. A function should just have one job, so you know what's going on, and therefore when you're programming it, you don't introduce bugs like this. I forgot that something else was using this function as well, and so it's caused this bug. So let's just go and have a look at generate the shell, which is our gravity system. So there we go, we're going to generate Perlin. And so, even if we've created that piece of land, that subcube already, it's going to go here. So we could tell it not to plant a tree, I guess. Let's do that. Let's do a hack. So we could say plant tree equals false. So if we write equals false up here, that will be the default value of plant tree. So we don't have to change any of the code in our generate shell or gravity system. Because we haven't added anything, it will just be set to false. So we can say else, or rather else if, or elif, plant tree equals true, then go and plant our tree possibly. So if there isn't a cave there, and if we're allowed to plant a tree, go and plant a tree. And that just means we can switch that on in generate terrain. So we're in this section, this block. So after we've said we're allowed to do a, as long as it doesn't equal I, i.e. Already exists, we can generate Perlin, and now we can say true. You can go and plant a tree. So let's just see. Oh, that'd be good if I've actually solved that bug now. So it was very mysterious. And oh yeah, we need to drop ourselves from less of a height. Let's just go and wander around a little bit. I'm kind of looking at these numbers. and they don't seem to be changing at all. So let's escape and just have a look. So it's naught, 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 naught. So it'd be like if that were a terrain, it'd be completely flat. So we do want some frequency here. And let's just add a frequency. Let's just try 100 as well and just see what numbers we get out. I can't remember how to properly balance these. So I'm just adding in some random numbers. Oh, here we go. Oh, we're getting some different ones now. So the highest I can see is kind of like 11, 12. Oh, we're getting loads over here. And it's basically crashed because there's too many trees and too many printouts. So tree system, I'll just comment out that, and then frequency, I think we need a very low number so they're kind of not so dense. So let's just add 5, and then tree chance we'll keep to 30, and we'll see what's going on. Okay, so loads of trees up there, and we are only getting one tree planted on one spot. Again, they're a little close together, aren't they? So maybe that frequency needs to be again a bit lower, and maybe the chance a bit higher. But we're kind of, because we're using Perlin noise, we're getting like clumps of trees together, which is quite realistic. And you can imagine, maybe you would use or design a model that kind of like blends together. Yeah, I quite like that. And it's not destroying the computer. Fantastic. Right. Thank you very much for watching. Leave any comments if you've got any suggestions or requests or anything, and I'll try and help you out. Oh, we've also got Collider, and the Collider is working. So now we can't walk through our trees, so we've got a much more interesting kind of terrain. So next time what we need to do is probably build our cave floor and see if we can get another layer going on and other things. So I just want to, on our main module, say that we've done the trees. We've got the basic trees going. Okay, thank you very much. See you next time.